Good science boils down to making as many high-quality observations as possible and then analyzing and interpreting them. At NASA Langley Research Center in Hampton, Virginia, a 5-year research program called the Joint Runway Friction Measurement Program is underway. This international effort is investigating aircraft losing traction on icy runways. This icing research program is having some groovy spin-offs. Let's meet with Tom Yeager and learn more about runaway runways.
Thanks, Shelley. I'm standing here this morning in our Aircraft Landing Dynamics Facility shop area. Behind me you can see one of our test carriages. We've got a display here of a landing gear system that we're looking at to evaluate from a standpoint of reducing the loads going into the fuselage. On my right here is a display showing some of the work that we've done to support the shuttle tire program that got started in the mid-70s and has been quite successful since then. We've done several modifications to the runway down there based on research data that we obtained here at our Aircraft Landing Dynamics facility in Hampton, Virginia. We've also done work in modifying the tire design and the brake unit that's used on the shuttle that's being flown later on this month from Kennedy Space Center. We do a lot of work looking at aircraft tread design, how the grooves are positioned, and minimize the hydroplaning potential that can occur during aircraft landing and takeoff operations on wet runways. You're viewing a typical aircraft landing gear tire touching down on a contaminated or ice-covered surface. And due to the reduced friction capability between the tire and the ice, it takes a considerably long time for this tire to spin up to a speed that's equal to the forward motion of the airplane. We're currently involved in the 4th year of a 5-year program with partnership with the FAA, Transport Canada, the National Research Council up in Ottawa, the National Defense Department out of Winnipeg, as well as several aviation organizations supporting this activity, where we're evaluating aircraft braking performance under winter conditions. These conditions include snow, ice, slush, and water. And to date, the majority of the tests have been taking place in North Bay, Ontario, which is about 2.5 hours north of Toronto. We've evaluated braking performance of a Falcon 20, a de Havilland Dash 8 airplane, an FAA Boeing 727 airplane, and a NASA Boeing 737 airplane. Coming up in this program, you'll be involved in a classroom experiment that will give you a better idea of how the coefficient of friction influences the motion of two objects, for example, pavements and tires. In our work here at the track facility, we've identified the fact that the higher the friction coefficient, the shorter the stopping distance is for an airplane operating on a runway, and the less chance he has of going off either the side or the end of the runway. Some of the equations that determine this behavior of vehicles operating on pavement surfaces will be explained to you in the classroom experiment, and I want to wish all of you good luck in conducting that experiment.